Welcome to Second Take, the show that focuses on the issues behind the news. South Africa's big radio astronomy project is set to make major strides this year. Joining me in our Johannesburg studio to talk about developments is Engineering News Senior Contributing Editor Keith Campbell. Keith, welcome to Second Take. Can you talk about the large science project that is taking shape in the Karoo? What milestones have been achieved and what can we expect this year?
Considerable progress has been made in the past couple of years on the Meerkat Radio Telescope project in the Karoo, and this year will see further significant and exciting advances. The most important immediate thing is that what is now called the Meerkat Precursor Array, what used to be called CAT-7, CAT being an acronym for Karoo Array Telescope, will be completed this year. By the end of last year, that is the end of 2009, 5 of the 7 dishes of the Meerkat Precursor Array had already been erected, and 2 of them had already achieved what are called interferometry fringes, which I'll come to in a minute. So that will be fully operational, fully finished by the end of the year. When I say fully operational, the Meerkat Precursor Array is intended as an engineering prototype, not as a major science instrument. It will start doing science at the end of this year, beginning of 2011, but its prime function is as an engineering test bed for the much bigger Meerkat. Meerkat will have up to 80 dishes in it. So this is a critically important year in the course of the Meerkat project. Among other things, for example, the dishes that are currently being erected are being manufactured in 2 different ways. One type is composed entirely of composites. The other type has a metal mesh embedded in the composite of the dish. The latter type with the metal mesh is easier to manufacture, but the metal mesh does restrict the wavelengths that the dish can receive. Now, the scientists are going to have to see if this restriction is acceptable or not. But next year, we'll see the choice of the design that will be used for the construction of the 80-dish Meerkat array. There's another important development this year. They're going to have to close down all activities for 3 months at the site because the International Square Kilometre Array Organization is going to be carrying out radio frequency interference measurements at the site. They'll be doing exactly the same thing at exactly the same time using exactly the same equipment in Australia. If you remember, the Square Kilometre Array is a €1.5 billion global project to build the biggest radio telescope ever. And South Africa and Australia are the 2 countries in the short list to host the SKA project. So the radio frequency interference measurements are a critically important step in the case of both countries to be selected as the host.
As you say, South Africa is bidding to host the SKA. What will happen to the Meerkat if we fail to win the bid to host the SKA in South Africa?
Well, the interesting thing about the Meerkat and the SKA and its Australian Meerkat's Australian counterpart, the Australian SKA precursor, or ASCAP, is that at a very important level, neither South Africa nor Australia can lose. If the SKA organization decides to put the SKA in Australia, South Africa will still have Meerkat, and it will still be one of the biggest and most powerful and most important radio telescopes in the world. Conversely, if SKA comes here, Meerkat will be incorporated into SKA, and the Australians will still have ASCAP, and that, again, will remain one of the most important radio telescope arrays in the world. So both countries, at a fundamental level, can't really lose. Both will have benefits from whatever the outcome is.
As a pure science project, one of the major economic spin-offs will be the development of scientists, engineers and technicians. What have been done in this regard?
Well, that's exactly true. In 2004, the SKA South Africa, which is the organisation responsible for South Africa's bid for the SKA and for the Meerkat radio telescope array, and indeed for South African involvement in all international projects in what's called the Radio Astronomy Reserve, which has been declared in the Northern Cape. In 2004, they launched a programme of bursaries, grants and fellowships to stimulate undergraduate and postgraduate professional, technical, artisanal training in engineering, technology and science. And since then, they have awarded 199 of these bursaries and fellowships and grants, of which roughly 2/3 have been for physics and astronomy, and 1/3 has been for engineering. The first year in which they were awarded was 2005. There were 9 awarded. For this year, 2010, 49 have been awarded. The Department of Science and Technology asked SKA South Africa to try and devote 30% of its budget to what is called human capital development, and they are on course to achieve this. It's actually apparently one of the biggest such programs in the world, but SKA globally is having a similar effect all over the world, including in developed countries. It's exciting young people to get into science and to get into engineering. It's certainly having that effect here. Part of this program has been the creation of 5 research chairs at South African universities. A research chair is a full professorship for research into radio astronomy and related disciplines. There's one each at UCT, Wits, Stellenbosch, Rhodes and the University of the Western Cape. So this is a major factor. People who go into astronomy do not necessarily stay in astronomy, but they are highly trained and highly analytical thinkers. The same applies for physicists, and the engineers working on SKA will be top flight electronics and other engineers. It will stimulate the wider sectors of science, technology and engineering in South Africa to quite a considerable degree for many years to come.
Keith, thank you very much, and thanks for joining us on Second Take. That is the Second Take show for today. Thank you for watching, and join us again next week for more news analysis.